In this video, we'll look at adding and subtracting fractions. This is our first question, 3 by 4 plus 4 by 5. When adding or subtracting fractions, it makes it a lot easier if we make the denominators same. To do that, we have to find the LCM. The LCM we can find by a few methods. I'll use the least common multiple method. I will use the prime factorization method rather. 4 can be split into 2 times 2. These are the two prime numbers that we multiply to get 4. And 5 is a prime number. So the LCM is 2 times 2 times 5, which is 20. So we have to convert both denominators to 20. First, we'll take 3 by 4 and we'll multiply 4 by 5 to make it 20. As I said, we have to convert the denominators. We have to convert both 4 and 5, which are the denominators, to 20. And when we multiply the denominator of a fraction by a number, we have to multiply the numerator as well. So I'm going to multiply the numerator by 5 as well. We do the same here. 4 by 5, we have to multiply 5 by 4 to make it 20. And we will do the same to the numerator so that the fraction remains equal. So this gives us 15 over 20 plus 16 over 20. When we are adding fractions where both denominators are same, we can write them like this. This gives us 31 by 20. So what we did was, we looked at the denominators of both the fractions. We found the least common multiple. We converted both the denominators to the least common multiple by multiplying by a number. And we did this, we multiplied the numerators for both fractions by the same number. This is an improper fraction. The numerator is greater than the denominator. Usually questions will ask you to write it in its simplest form, which means we need to turn this into a mixed fraction. And this is how we do that. We write them like this as we normally divide numbers. What is the closest we can get to 31? If we multiply 20 by 1, it gives us 20. We cannot multiply 20 by 2 because that would make it 40, which is greater than 31. We don't want that. When we subtract, we get 11. Now there are two ways of converting or writing this as a mixed number. One method is you can draw arrows like this. Right now, the number on the left is the divisor. The number at the top is the quotient, and the number at the bottom is the remainder. We draw arrows like this in the counterclockwise direction, meaning the quotient is written on the left, the remainder is written at the bottom, and rather the divisor is written at the bottom, and the remainder goes at the top. Basically, this is how we write it. So the quotient was 1, we wrote that at the left. The divisor, we wrote that at the bottom here. And the remainder, we wrote it above. This is how you convert an improper fraction into a mixed number. This is our second question, 1 by 3 plus 1 by 8. Again, the denominators for both are different. We have to make them the same, and for that, we find the LCM. I'm going to be again using prime factorization. 3 is as it is, it's a prime number. We cannot break this down into more prime numbers, but we can factor 8 into prime numbers. 2 times 2 times 2. So the LCM is 2 times 2 times 2 times 3, which gives us 24. We convert 3 to 24 by multiplying it by 8, and we multiply its numerator 1 with the same number 8 so that this fraction remains equal. Then we take 1 by 8, and we need to convert 8 here to 24 as well. So we need to multiply 8 by 3, which will give us the LCM 24, and we do the same to the numerator, so the fraction remains equal. So this gives us 8 by 24 plus 3 by 24. This gives us 11 by 24. The denominators are the same, so we can write them once and we add the numerators. We cannot simplify this any further. 11 is a prime number, and there is no number that we can use to divide both of these numbers. So this is our answer. This question is 5 by 6 plus 6 by 9. And we do the same process again. Both denominators are different. We find the least common multiple. For 6 and 9, I'm going to use the prime factorization method. 6 can be written as 2 times 3. Both are prime numbers, 2 and 3. 9 can be factorized as 3 by 3. So the LCM is 3 times 3. 3 occurs twice in 9 times 2, which occurs once in 6. So 3 times 3 is 9. 9 times 2 is 18. So now we have to convert the denominators in both the fractions to this LCM 18. Then we can simply add the numerators. We have to multiply 6 by 3 to get 18, and we do the same with 5. Then we have 6 by 9. We have to multiply 9 by 2 to get 18, and we do the same with the numerator. This gives us 15 by 18 plus 12 by 18. And we get 27 by 18 when we add the numerators. Again, this is an improper fraction. The numerator is greater than the denominator, so we will convert it into a mixed number. If we multiply 18 by 1, we get 18. We can't multiply 18 by 2 because that would make it 36, which is greater than 27. And we subtract. We get 9. Again, they switch positions. Right now the quotient is at the top. At the bottom we have the remainder, and on the left we have the divisor. The quotient is going to move to the left position. The divisor is going to move to the bottom position, and the remainder is going to move to the quotient position. This is a mixed number, and we can simplify this further. We can see that 9 and 18. 18 is a multiple of 9. So we can simplify. This gives us 1 by 2. Now let's look at subtracting fractions. It's the same process as addition. I'm going to solve a few examples. We have 3 by 4 minus 1 by 3. The denominators are different. We need to find the LCM by using prime factorization. 4 can be factorized as 2 by 2. 3 is a prime number, so we can't factorize that. So the LCM is 2 times 2 times 3, which is 12. So we can write, so now we have to convert 4 and 3 into 12. When we multiply 4 by 3, we get 12. We have to multiply its numerator with the same number. And then we do the same for 1 by 3. We need to multiply 3 by 4 to get 12. And we do the same with its numerator. With fractions, whenever you multiply the denominator by a number, you do the same with the numerator to make sure the fraction stays equal. So this becomes 9 by 12. This becomes 4 by 12. And if we subtract, we can write it like this. 5 by 12. We cannot simplify this any further. It's not an improper fraction, so we don't need to convert this into a mixed fraction. And so our answer is 5 by 12. The next question we have is 3 by 5 minus 1 by 3. The denominators are different, but they're both prime numbers. When you have two denominators that are both different prime numbers, the easiest method to find the LCM is to just multiply them. 15 is the LCM. We have to convert both denominators to 15. 5 times 3 is 15, and I multiply the numerator with the same number, so the fraction stays equal. 3 times 5 gives us 15, and I will multiply the numerator with the same number to make sure the fraction stays equal. This gives us 9 by 15 minus 5 by 15, and this gives us 4 by 15. This is our answer. We cannot simplify it further. The numerator is not greater than the denominator, so this is our answer. This is our last question for this video, 1 by 2 minus 2 by 5. Again, we find the LCM. As I said before, if you have two denominators and they are both different prime numbers, we can simply find the LCM by multiplying them. So now we convert both denominators to 10. 2 multiplied by 5 is 10, and we multiply 1 with the same number. We take 2 by 5. We multiply 5 by 2 to get 10, and we multiply the numerator 2 with the same number. This gives us 5 by 10. This gives us 4 by 10. So we can write this as 5 minus 4, because the denominator is same for both fractions. We can write this as 5 minus 4, and we write 10 once because the denominators are the same. And this gives us 1 by 10. We cannot simplify this any further, and so this is the answer. That was today's video. I hope you liked it, and if you did like the video, be sure to like, share, and subscribe, and I'll see you in the next video. Thanks for watching.